Hello friends, today I'm going to show you how to solve exact differential equation. That means differential equation of this form, and to be exact differential it must satisfy this condition. So let's start. So exact differential equation, that means equation of this form m dx plus n dy is equal to 0, such that partial derivative of m with respect to y is equal to partial derivative of n with respect to x. This must be equal to this. Then only this equation is said to be exact differential equation. Now let me explain how to solve this. So it is very simple. Just remember this pattern, that to solve it, solution of this equation. So we're going to integrate this first term. We're going to integrate this integration m dx. So m dx with respect to x. Here y will be considered as constant, and then we are going to integrate the terms which doesn't contain x. So terms of n not containing x dy with respect to y we are going to integrate. Then we need a constant here, that is c. So that's how we're going to solve this kind of equation. Now let me give you one example. Suppose we need to solve an equation. Suppose, let me write the equation. Now first let us take this example. Suppose we need to solve this equation. Okay, I have taken this simple equation, then I will show you more examples. Okay, so first, in order to explain how to apply the method, just I have taken a simple example. Okay, so now what we're gonna do here, we have to consider this is as m dx, and we have to consider this part as n dy. So first we are going to check, is this exact differential or not. How to check that? We have to check, does it satisfy this condition. Okay, so what we're going to do, we're going to differentiate m partially with respect to y. So let's find del m by del y. So if you differentiate this with respect to y, then what you will get? Then you will get 1 only. Okay, you may check yourself. And if you differentiate n with respect to x, then what will you get? Differentiating x with respect to x, you will get 1, and y will be constant, that's going to be 0. 2 will be constant, that's going to be 0, because we are doing partial differentiation. Okay, that's why. So hope you have understood this. Now that's going to be equal to 1. So in partial differentiation, if you are differentiating an expression with respect to x, then if there is any term which consists y, then that will be considered as constant. So hope you have understood that. So now, so here you can see, as del m by del y is equal to del n by del x, that's why. So since del m by del x, sorry, not x, del y is equal to del n by del x, so this given equation, suppose let it be equation number 1. This equation 1, so let me scroll down. Equation 1 is exact differential equation. Exact differential equation. So hope you have understood this. Now what is the next step? So we are going to follow this pattern. Okay, so we are going to integrate m with respect to x, and we are going to integrate the terms which doesn't contain x. Okay, so that's why. So our solution will be integration m, here m is x plus y minus 10. This is m x plus y minus 10 dx, then plus integration. So here from n we are going to take those terms which doesn't contain x. So here terms not containing x is minus y minus 2, so we are going to take that minus y minus 2 dy, and we need a constant here c. So hope you have understood, because derivative of constant is 0 and right hand side of this equation number 1 is 0, isn't it? So that's why we need a constant here. So hope you have got it. So now let me scroll down the page. So sorry, so now here integration x dx plus, as y should be considered as constant in this case, so y dx. So what we have taken, y is constant here in this case. So if you notice this, if you see this, what we have done here, we have taken y as a constant. Okay, that's how we have to integrate. Minus 10 integration dx plus, and we will get, sorry, that will be minus here as there is minus y, so minus integration y dy minus 2 integration dy is equal to c. Now let us integrate. Integration of x with respect to x, that's going to be x squared by 2, and integration of dx is x, so we get xy, then integration of dx again x, 10x here, so integration of y will be y squared by 2, then minus integration of dy, integration of dy is y. So that's our answer. That's how we can solve. So I have taken here a very simple question. So let me take another differential equation having exponential functions. Okay, so let me take that. Now let us solve this equation. So in order to solve that, before we solve, let me check is this exact differential or not. So we have taken here, this is m and this is as n, so we know the condition to be exact differential. So let's find del m by del x, sorry, not del x, del y. So let us differentiate. So partial derivative of m with respect to y is equal to del by del y 1 plus 3 e to the power x y, and derivative of 1 is that's going to be 0, and then we have 3 del by del y e to the power x by y. So as it is partial derivative, we are going to take this y, sorry, not y, x as constant. So we are going to take x as constant. So here you see this function is of this form, e to the power f of y. So if you differentiate with respect to y, then what you will get, e to the power f of y into again derivative of f of y. You will get that, isn't it? Now here f of y is, we have x by y, and if you differentiate it, take considering x as constant, if you differentiate it, then what you will get, minus x by y square, because derivative of y with respect to y, derivative of not y, 1 by y with respect to y is minus 1 by y square, isn't it? So taking x as constant, derivative of x by y with respect to y, it's going to be minus x by y square. Then so what will be this result? This will be e to the power x by y minus x by y square, and we have 3 here. Here you can see 3. So if you multiply 3, then you will get minus 3x by y square e to the power x by y. That's what we will get. So now let me clean this part. Wait. So now we will find del n by del x. Okay, that means we are going to differentiate partially n with respect to x. So let us write del n by del x, del n by del x. So here you can see, if you differentiate 3 e to the power x by y into 1 minus x minus y, sorry, x by y. So here this part should be considered as u and this should be considered as b. So we are going to use the product rule. We know the derivative of u and v, product of u and v, its derivative is given by u derivative of v plus v derivative of u. So here our u is 3 e to the power x by y, so 3 e to the power x by y. And if you differentiate this with respect to y, and sorry, not y, with respect to x, and then we are going to take y as constant, this y should be taken as constant, then what you will get? Then you will get minus 1 by y, okay, then plus v derivative of u, that means here v is 1 minus x by y, and derivative of u means we are going to differentiate this term, okay, with respect to x now, not y, with respect to x. If you differentiate it with respect to x, 3 into del by del x e to the power x by y, here x by y, you can assume this e to the power x into 1 by y. Here 1 by y should be taken as constant, as we are doing partial derivative. So we know ddx of e to the power ax, where a is constant, that is given by a e to the power ax, isn't it? So that's why here we will get 3 by y e to the power x by y. So that's what we will get here, okay. So hope you have understood this. So now let me simplify this. So first, if you simplify this, then what you will get? So you will get del n by del x is equal to, so minus 3 e to the power x by y by y, then plus 3 e to the power x by y by y. When you will multiply with 1, then you will get this, then, and when you will multiply this with minus x by y, then what you will get? Minus thrice x by y square e to the power x by y. So here these two terms gone, so we have got only minus thrice x by y square into e to the power x by y. And here you can see these two are same, so we can say here del n by del x is equal to del m by del y. So that's why our equation number 1, that is the given equation, is exact differential. So we can write, since del m by del y is equal to del n by del x, so equation 1 is exact differential equation. So now let us solve this. So how to solve such kind of equation, that I have already shown you that what to do. We have to integrate m with respect to x, considering y as constant, and then plus we are going to integrate terms, integrate the terms of n not containing x, then the y is equal to, then there will be a constant, as here you see on the right hand side it is 0, and we know derivative of c is 0, that's why here it will be c, constant. So now you see, so what is m here? M is 1 plus 3 into e to the power x by y. So let us put 1 plus 3 into e to the power x by y dx. And what are the terms not containing x? So here you can see, so you are not going to have any term which doesn't contain x in n. So here if you multiply this one with this and this one with this, then again here all the terms in n will consist at least one x, okay. So that's why So there is no such term that doesn't contain x. So that's why we are so that's why this is gonna be 0. Okay, so then what we are going to write here, you see, that's gonna be equal to c. Okay, now let us integrate this. So integration dx plus 3 e to the power x by y dx is equal to c. Okay, so as we are going to consider y as constant here and derivative of dx is x, so we will get e to the power x by y here 1 by y. So what we have done, we have considered that e to the power x and 1 by y as constant, isn't it? Here 1 by y as constant. If you integrate this, so we know integration of e to the power ax is given by e to the power ax plus divided by a plus c. So that's how we used to integrate, isn't it? So same thing is done here, is equal to c, and if you simplify this, then you will get x plus thrice y e to the power x by y e to the power x by y is equal to c. So that's our answer. That's how we can solve. So hope you have understood. Now let me show you one more example again. Okay, another type of a differential equation. Now here you see again I have taken another type of differential equation which consists trigonometric functions in this equation. So I am showing you different kind of differential equations, so you can solve all the type of differential equations which are exact differential equation. Okay, so here similarly we are going to take again this one as m and this one as n. So let me check is this exact differential or not. So that's very simple. Differentiate m with respect to y partially, and if you differentiate it with respect to y, so here you can see only this term consists y, this first term within bracket, and here sec square x should be taken as constant, and derivative of y with respect to y will be 1. So 1 into sec square x, that's only sec square x. Hope you have understood this. Now let us find del n by del x. If you partially differentiate this n with respect to x, the term consisting x is this 10x, isn't it? 2y will be considered as constant as we are partially differentiating with respect to x. So that's why. So and derivative of 10x is nothing but sec square x. So here you see this is equal to this del m by del y is equal to del n by del x. So since del m by del y is equal to del n by del x, so suppose this is equation number 1. Equation number 1 is exact differential equation. So now let us solve this. How to solve this? So I have already told you that integrate m with respect to x, integration of m with respect to x. Here y should be taken as constant. Then we have to integrate the terms of n not containing x dy, then constant c. So let us integrate this m with respect to x, then y sec square x plus sec x tan x dx, and here in n you see 2y is the only term. This 2y is the only term which doesn't contain x. So we will take here integration to integration y dy, okay, is equal to c. That's what we will take. So now how to integrate this? So as we are going to, in this case we are going to consider that y as constant, so y sec square x plus here dx should be written. Okay, let me clean this. Dx plus integration sec x tan x dx. Okay, plus 2y integration of y with respect to y is equal to c. So in this case what we have taken y as constant, isn't it? Y is constant in this case. So now integration of sec square x, it is nothing but 10x, and integration of sec x 10x is sec x, and 2 into integration of y will be y square by 2, and 2 to gone, sorry, is equal to c. So that's why our result will be y 10x plus sec x plus y square is equal to c. So that is your solution. That's how we can solve. So hope you have understood, and if you have understood, please share the video with your friends, and if you are new to my channel, subscribe the channel, and please help me to grow my channel so that I can create more contents for you, inspire me to create more contents, new contents for you. Thank you for watching. See you in the next video.